Hello students, welcome to Math Practice. In the previous video on definite integrals, we had seen some examples and the concept. In this video, we are going to discuss many other examples for definite integration, all with a different technique. Watch the video till the end to know which technique to apply to which example. Now these are some special properties. I will explain each of them with the help of examples. So the first example, we have to evaluate the following integrals. In this, we are going to use the property integral from minus a to a of fx dx will be equal to 2 into integral 0 to a fx dx if the function is even, and it will be 0 if the function is odd. Now even function means f of minus x and f of x are same. And odd function is f of minus x is minus of f of x. Let us understand this by a simple example. Integral of cos x dx from minus pi to pi. Now cos is an even function, meaning if you take cos of theta and if you take cos of minus theta, both will have the same value. To understand this, let us simplify. Say cos of pi, that is also minus 1, and cos of minus pi when you go from the other direction, that will also be minus 1. But sine on the other hand is an odd function. What does this mean? Say sine of pi by 2 is 1, but sine of minus pi by 2 is minus 1. So it is an odd function. Now since cos is an even function and it is minus pi to pi, so we can write this as 2 into integral 0 to pi cos x dx. Integral of cos is sine, so just evaluate within the limits. So it is 2 into bracket sine pi minus sine 0, which is equal to 0. Correct? Second one is for minus pi to pi sine x dx. Now since sine is an odd function, directly we can say that the integral, this integral minus pi to pi sine x dx will be equal to 0. So this is a useful property. Now in this next example, we have to find integral of mod x dx from minus 1 to 2. Now see, always remember you can be asked examples based on mod function in integration. So whenever mod function is there, first of all, you just divide it into minimum two parts, one for the negative and one for the positive, because mod function is defined in a different way for negative and for positive. You know that, correct? So now you have integral mod x dx. It is from minus 1 to 2. So first we will divide it into minus 1 to 0 and then 0 to 2. In this we are using the property that integral a to b fx dx is equal to integral a to c plus integral c to a. Correct? So over here minus 1 to 0. That means here mod x will take the value minus x. You know that for negative. And for positive, it will take the value x. So for 0 to 2, it will be integral of x dx. Obviously, you know minus x integral is minus of x square by 2 and x integral is x square by 2. Put the limits and now you know how to evaluate definite integral. Upper limit value minus the lower limit value. So this will give you the answer 5 by 2. Next is integral of greatest integer function. Box x means it is the GIF function, greatest integer function. The integer which is less than or equal to the given value, that is the greatest integer function. From 0 to 5 box x dx. Now see, here we are using a simple property as I told previously. If you have integral a to c and in between if you have b, you can write it as a to b plus b to c, the limits. Now since it is 0 to 5 over here, because see here it is the greatest integer function, so the value of this box x will be different in each of the case. So we have to divide it into 0 to 1, 1 to 2, 2 to 3, 3 to 4 and 4 to 5. 0 to 1, that means say 0, 0 0.5, anything. The greatest integer which will be less than or equal to that value will be 0. So first term is 0. Second term is box x, what value will it take from 1 to 2? Now remember 1 to 2 means any value between 1 and 2. Say if I say 1.6, then it is what is the greatest integer less than or equal to 1.6? It is 1. So for this part it will take the value 1. So I have written integral 1 to 2 1 dx. Similarly integral 2 to 3 2 dx, integral 3 to 4 3 dx, and for integral 4 to 5 all the values which are less than or equal to the given value over here will be 4. So now you know how to integrate. Integral of 1 is x. So you have first term 0, second term 1 into the box value of x between 1 and 2. Similarly 2 and 3, 3 and 4, 4 and 5, upper limit minus lower limit. So this will give you the answer 10. Now we will start taking different type of examples and we will use different techniques for each of the examples. First one, you have to find integral 0 to pi by 2 cos raised to phi x dx upon sin raised to phi x plus cos raised to phi x. Now see, over here you have integral 0 to pi by 2. There is a property that if you have integral from 0 to a, you can write it as, instead of x you can write it as a minus x. Correct? The property is shown over here. So here why we are doing this, that also we'll understand as we go further. So wherever there is x, you will write pi by 2 minus x. A minus x means over here pi by 2 minus x. So first the numerator will be cos raised to phi pi by 2 minus x. That means if you are having cos of pi by 2 minus x, you know that is sin x. So now it will become sin raised to phi x. Similarly in the denominator it will become sin raised to phi will become cos raised to phi, and cos raised to phi will become sin raised to phi, because pi by 2 changes the function. So now what we are having is the same integral. The given integral, say that is 1, and the same integral we have written in the form of 2. Add 1 and 2. So what will you get? Integral 1 dx. See how simple it becomes, correct? So this will become integral. Whenever, how will you know how to use this method? Just see the numerator and the denominator. In the numerator cos raised to 5 is there. In the denominator sin raised to 5 plus cos raised to 5 is there. So try to make it in that manner. Now integral 1 is x. Put the limits, you get the answer pi by 2. 2i. Why? Because I will be, just we are adding both the terms. So 2i is equal to pi by 2, means I is pi by 4. Now we have discussed about odd and even functions. So try to solve this example. See how easy it becomes from that concept. It is integral of minus pi by 2 to pi by 2 x cube plus x cos x plus tan raised to phi x plus 1 dx. Now it is integral minus a to a form. First term is x cube. Now you know x cube is an odd function. Minus 2 cube is minus of 2 cube, means f of minus x is minus of f of x. It is odd function. Cos x is even, but x cos x will be odd. Tan raised to 5 odd. So you will just remain with integral 1 dx, and then when you solve it you will be getting the answer as pi. Next one, show that integral 0 to a fx gx dx is equal to 2 into integral 0 to a fx dx if f and g are defined as f of x is equal to f of a minus x and g of x plus g of a minus x is equal to 4. Now this is to demonstrate the simple use of the property which we have seen. Integral is 0 to a fx gx dx. Now you know if it is integral 0 to a, you can write a minus x instead of x. So it will be 0 to a f of a minus x, g of a minus x. But f of a minus x is given to be f of x. And g of a minus x is equal to 4 minus g of x. This is also from the given statement. So now what you have is, just simplify it. You will be having 4 into fx dx minus 0 to a fx gx dx. But what is it? 0 to a fx gx dx is integral I itself. So you have got I is equal to 2 into integral 0 to a fx dx. Next one, integral pi by 6 to pi by 3 sin x plus cos x upon root of sin 2x dx. Now since sine 2x is given and the numerator is in the form of sin x and cos x, obviously we will use trigonometric conversion. So sine 2x is 2 sin x cos x. Now you know that sin x minus cos x whole square is sin square plus cos square minus 2 sin x cos x. So sin square plus cos square is 1. So I can write 1 minus 2 sin x cos x. So what is 2 sin x cos x? It is 1 minus sin x minus cos x whole square. You will just come to know why we have done this. Now suppose in this case if I take sin x minus cos x as t, then take the derivative on both the sides. So it will be cos x, derivative of cos is minus sin, so minus minus plus. Cos x plus sin x whole dx is equal to dt. So now what is this? This is the numerator of our given integral. That is the reason why we have taken sin x minus cos x whole square and why we have taken sin x minus cos x as t. So since we have used substitution method, we have to change the limits. Don't forget to change the limits whenever you use the substitution method. Now when x is pi by 6, what will be t? T is sin x minus cos x, means sin pi by 6 minus cos pi by 6, which will be 1 minus root 3 whole upon 2. Similarly, when x is pi by 3, t will be root 3 minus 1 upon 2. So now our integral I will become 1 minus root 3 by 2 upon root 3 minus 1 by 2. The numerator is dt upon root of 1 minus t square. Correct? Now, remember it is of the form minus a to plus a. And over here, this can be written as 0 to a. 2 into 0 to a using this property. So this we can write as 2 into integral 0 to root 3 minus 1 by 2. Why? Because 1 minus root 3 by 2 is minus of root 3 minus 1 by 2. Okay. So we can write it as 2 times 0 to root 3 minus 1 by 2 integral of dt upon root of 1 minus t square. As I told you, we want to use this property, then what is the condition? Our function should be an even function. In fact, looking at it, it is obvious it is an even function, but I have showed over here why ft is an even function. Ft is 1 upon root of 1 minus t square. Instead of t, if I put minus t, then also I will be getting same ft. So ft is an even function, and so we are using this property. So now I is equal to 2 times integral 0 to root 3 minus 1 by 2 dt upon root of 1 minus t square. Now you know this is of the form dx upon root of a square minus x square. And the integral is sine inverse of x. So over here it is 2 into sine inverse of t from 0 to root 3 minus 1 by 2. You know that sine 0 is 0. So the answer will be I is equal to 2 into sine inverse of root 3 minus 1 by 2. Next example, integral of 1 to 3 dx upon x square into x plus 1. You have to show this is equal to 2 upon 3 plus log of 2 upon 3. Now looking at the integral, we have studied integration. So in one of the previous integration videos, partial fraction method was explained. So you are having 1 upon x square into x plus 1 type. So by partial fraction method, I have put the link in the description box so you can go through it. By the partial fraction method, you will be having this will be equal to a upon x plus b upon x square plus c upon x plus 1. Taking the LCM, it will be a into x plus 1 plus b into x plus 1 plus c into x square. We have done many examples of this kind. So now when you compare both the sides, first thing is I am comparing the constant term, because it becomes very easy. On the left hand side only constant term 1 is there. So 1 is equal to the constant term on the right hand side is just b. So b is 1. Now compare coefficient of x on both the side. On left hand side it is 0. On right hand side it is a plus b. So putting the value of b as 1, a is minus 1. Similarly, comparing coefficient of x squared, you get c as 1. So what we have got is a is minus 1, b is 1 and c is equal to 1. So looking at this kind of example, you should know we have to use the partial fraction method. So in our example, we put the values of a, b and c. So I is equal to integral 1 to 3 minus 1 by x dx, 1 to 3 1 upon x square dx, integral 1 to 3 1 upon x plus 1 dx. You know 1 upon x integral is log mod x. 1 upon x square means x raised to minus 2, integral is x raised to minus 1 upon minus 1, and 1 upon x plus 1 integral is log of mod x plus 1. Put the values upper limit minus lower limit. Use the property of log. Log a plus log b is log a into b, and log a minus log b is log of a upon b. Using these properties we get 2 by 3 plus log of 2 by 3. Hence we have proved that integral 1 to 3 dx upon x square x plus 1 is equal to 2 by 3 plus log of 2 by 3. Mod 2 by 3 will become 2 by 3 because both are positive. Next important example, integral minus 1 to 3 by 2 mod of x sine pi x dx. Now our function is mod of x sine of pi x. I have written this, I have divided it into two parts. Basically you should be dividing it into three parts. I will explain step by step why we have defined fx in this manner. I told you when mod function is there, generally the function is defined in a different way for negative and positive value of x. Over here, the first case when x is negative, that means x is between minus 1 to 0. In this case, sine pi x will be greater than or equal to 0. Reason is the values of sine will be in the first and second quadrant where sine is positive. So fx will be defined as x sine pi x. Second case, we cannot directly take 0 to 3 by 2. The reason is because sine is a cyclic type of function, so it will behave differently between 0 and 1, and next case will be 1 and 3 by 2. So between 0 and 1, sine pi x will again be positive, first and second quadrant. For the third case, when x is between 1 and 3 by 2, that means sine of pi, when x is 1, it is sine of pi. That you know it is 0. When x is 3 by 2, that means sine of 3 pi by 2, that will be minus 1. So this will be the third quadrant, and in this case you will be having over here sine to be negative. So fx will be defined as minus x sine pi x. That is the reason we have divided into three parts. But now what we can do is combine the first and second part because sine is positive. So for minus 1 to 1, sine will be, the function fx will be defined as x sine pi x, and for 1 to 3 by 2 it will be defined as minus x of sine pi x. So now we have I is equal to integral minus 1 to 1 x sine pi x dx minus integral 1 up to 3 by 2 x sine pi x dx. Now for the first term, you know that over here sine is an odd function, but x sine x therefore will become an even function. So the first term minus 1 to 1 can be written as 2 into integral 0 to 1 x sine pi x dx minus the second term as it is integral 1 to 3 by 2 x sine pi x dx. Now you know that over here what is the integral of it? Integral of it, you will be applying the rule of integral u v dx. Integral u into v dx is u into integral v dx minus integral du by dx integral v dx. So now that rule is very clear, we have discussed previously. So over here your first function u is x and the second function is sine pi x. And you know integral of sine pi x is minus cos pi x upon pi. So put those values. For the first term you will be getting minus x cos pi x by x plus sine of pi x by pi square. And the limits are 0 to 1. In the second case same integral but the limits are 1 to 3 by 2. So now put the limits, upper limit minus lower limit. Take care while doing the calculations. When you simplify it you will be getting this as 3 by pi plus 1 upon pi square. Next example, integral 0 to pi by 4 log of 1 plus 10x dx. Now again over here we'll be using the property, if here it is integral 0 to a type, So instead of x you can write a minus x. So instead of x we will write over here pi by 4 minus x. Now just check it out why we are doing this, because we know the formula of tan of x minus y, that is tan x minus tan y upon 1 plus tan x tan y. So just put the values. Tan pi by 4, you know tan pi by 4 is 1. So now after simplification you get this as integral 0 to pi by 4 log of 2 upon 1 plus tan x. So now log function log a upon b is log a minus log b. So this is equal to integral 0 to pi by 4 log 2 dx minus integral 0 to pi by 4 log of 1 plus 10x dx. But the second term is our original integral I itself. This is the reason why we are doing this. So now we have I is equal to integral 0 to pi by 4 log 2 dx minus I. So 2I is integral 0 to pi by 4 log 2. You know log 2 is constant, integral 1 is x. Put the limits, pi by 4 minus 0 is pi by 4. So 2I is log 2 into pi by 4. So I is pi by 8 into log 2. Next important example. I is equal to integral 0 to pi x upon 1 plus sin x dx. Now over here again we use the property integral 0 to a type is there. So instead of x you can write a minus x. So here you can write pi minus x wherever x is there. So now why we are doing this? I think it should be now clear, because first term will become pi upon 1 plus sin x and second term will become x upon 1 plus sin x, which is our original integral I. So bring it on the left hand side, you get 2I is equal to pi into integral dx upon 1 plus sin x. So now our integral I which we need to integrate is pi by 2 integral 0 to pi dx upon 1 plus sin x. Okay. Now over here next thing is you multiply by the conjugate. 1 plus sin x, multiply numerator and denominator by 1 minus sin x. So numerator will become 1 minus sin x, denominator 1 square minus sin square. So that is cos square x. So now it is pi by 2 integral 0 to pi 1 minus sin x upon cos square x dx. So simplify it. It is pi by 2 into integral 0 to pi, first term will become dx upon cos square x, second term will become minus sin x upon cos square x. So let the first integral be I1 and second be I2. The first integral is simple, integral of sec square, that you know it is tan x. Put the limits, tan pi minus tan 0, both are 0. So first integral has become 0. Now I2, the second integral is integral 0 to pi minus sin x upon cos square. Now I think looking at this type of example, since the derivative of cos is minus sin, it should be clear that we will use a substitution method. We will substitute cos x as t. So minus sin x dx is dt. Always remember to change the limits. When x is 0, cos 0 is 1. When x is pi, cos pi is minus 1. So I2 is equal to 1 to minus 1 dt upon t square. The integral is 1 upon t. Put the limits, that will be equal to 2. So our final answer will be integral I is equal to pi by 2 into 0 plus 2. That is I is equal to pi. So students, integration is a very vast topic. We have covered it in 6 parts. In this second part of definite integration, we have tried to discuss all different techniques and different type of examples. So do like and share the video and subscribe to the channel. The playlist for integration is also given.